Hello, my dear friends, and again we are back with another problem, and we are going to learn how to solve such kind of problems. Now, the expression looks very intimidating, where there are lots of decimal numbers, and we really don't like to multiply decimal numbers, and it becomes cumbersome. So, hence, whenever you get such expression, always remember that the person who has said this question doesn't want you to, or doesn't let's say he's not intending to check whether you know calculations or how to do calculations faster, but rather he is checking whether you have multiple approaches to solve the same problem. And that's what we are going to do. We are not trying to, we will never go and calculate using our the method, common methods of multiplication, but rather we will try to use algebra to solve this. Okay, so if you notice, there are cube terms here. So there are cube terms. This is one observation. Cube terms are there. And the other observation is 0.87 and 0.13. Very beautiful numbers. So 0.87 and 0.13. If you see, they add up to 1. Isn't it? So this has something to do with this then. Okay, and let's inspect the denominator. There is square term. Then there is 1 and the other product. And then this is another square term. And this 0.87 is coming from here, and this 0.13 is coming from here. So it is indicative of something. So what is it? So if you see, let us say A is equal to 0.87, okay, and B is equal to 0.13. Let's say it becomes easier to see that the expression becomes A cube plus B cube, isn't it? A cube plus B cube, and the denominator becomes A squared minus AB plus B squared. Now by the moment you write this, your mouth starts watering. That we know already. Why? Because A cube plus B cube is A plus B, and this is A square minus AB plus B square, isn't it? A cube plus B cube is always like that. So, and the denominator is A square minus AB plus B square. Okay, and if A square minus AB plus B square, if this item is not equal to 0, assuming this is not equal to 0, then we can cancel both, isn't it? Both of them cancel. So what did I say? A square minus AB plus B square should not be 0, which is appearing not to be 0. So let's say if it is not equal to 0, only then you can cancel. Why? Because division by 0 is not allowed otherwise. So what do you get? Simply A plus B as the remnant, right? So A plus B, this is what is the final thing. Did you notice something, guys? That the entire expression is reduced only to adding A plus B, which we have already done, and that was 1, correct? So this is 0.87 plus 0.13, and that is equal to 1, correct? So this method of algebra, that is understanding of algebraic identities, can help us in arithmetic also, isn't it? That is what is the learning. So tomorrow, if there is a let's say you have to find out 0.99 cubed, okay, let's say this you have to do. Now this appears to be a quite cumbersome multiplication if you go with the regular method, but if you do this 1 minus 0.01, isn't it? It becomes much easier to do, isn't it? So hence now you can use the identity, expand this, calculate. Playing with powers of 1 is much easier than playing with powers of 9. So hence you can use this method to find out the value of 0.99 cube. So that is where algebra plays a lot of a lot of important role in arithmetic also, right? Okay, so that is the learning of this problem.